But today we're going to be doing the mill turn live event today. We're going to be, like I said earlier, we're going to be creating the 3D model from scratch because we did a live event recently on mill turn, but you guys wanted to request it again. So we're going to start from the very beginning in CAD, creating the drawing in the 3D model, and then creating the toolpath in mill turn to turn down the stock and do some milling operations with live tooling on the lathe. So let's get started here. I'm going to do some really basic programming, drawing, and 3D modeling here so that you guys can follow along. I think you guys liked that last time with the CAD webinar that I did. So we'll go here to the top. You can see in our newer versions of BobCAD, we've got this what they call ribbon bar layout. Very similar to any Microsoft Office program like Word or Microsoft Excel. You can see the different tabs up at the top with the different functions that you need to use. So we have them all grouped together, I think, a little more easily to find and utilize the software program in terms of CAD here. You can see at the top, we've got this tab, Create 2D. We've got a shape library of some predetermined shapes here. What I'm going to go into is I'm going to use the shape library. I'm going to use this hex shape. I think I normally use outer polygon. The only difference with the inner versus outer is the diameter that you're creating, whether you're creating the OD of the hex shape here based on the sides or based on the points. And I usually have it as outer polygon so that you can type in the actual OD of the hex here. So let's stick with the dimension of 2 inches that it normally stays in here. So again, all I did was go to Create 2D, Shape Library, and I click on the shape here under Shape Library to bring down the drop down here. And I'm going to do the second from the last on the right here, up at the top right, outer polygon. I could type in a dimension here. I'm going to leave it at 2. I can type in the number of sides I want for my polygon. I'm going to leave it as 6 for a hexagon. And number 2 is, I believe if I want to rotate it, what is number 2 here? Yeah, number 2 is some kind of rotation. I'm going to leave that at 0 as well. So it's just going to be the default numbers, and I'm going to scroll down and click OK. I'm just going to leave it right there at the center, right there. And then I'm going to hit cancel. Then I'm going to create a circle for the OD of the part. I'm going to go here to the top, go to arc, and let's make it a little bit smaller than 4 inches that it comes in as the diameter. I'm going to type in 3, and I'm going to scroll down and click OK to place that circle outside of the hex. Now you can see all I've got, I'm rotating this around by clicking and holding the scroll wheel and moving my mouse. If you guys don't have a mouse, I really recommend it for BobCAD to be able to get into the 3D modeling portion of it. Would be very difficult just using the trackpad on your laptop. But if you need to use the different views up at the top here, we have our top view. And if you need to look at it on an angle, you can drop this standard view down and change it to one of your isometric views. I normally have it as, what do I normally have it as? I normally have it as ISO 2. So that you're looking at it on an angle and you're sort of looking at the first quadrant, like from behind it, I guess you could say. So anyways, we've created a hex shape and we've created a circle, and I'm going to go to Create 3D and create the 3D model of it. I'm going to go to Extrude Boss. I'm going to select my hex shape, and I'm just going to extrude it out. Let's do 1 inch. I'm going to make it as easy as possible for you guys. Just do a hex shape with all the default numbers. Do the circle. I did change the default number to 3 inches for the OD of this. And I'm going to change, I'm not going to change anything at all for the Extrude Boss here. Just leave it at 1 inch. Scroll down and click OK. And then I'm going to stay in the Extrude Boss function and extrude out the OD. So I'm going to either window select like this, drag a box over the circle, or just click on it. Now I don't want it going inside of the hex shape. I want it going in the opposite direction. So in positive direction, I'm going to 0 that distance out. And I'm going to hit Tab so that it updates. BobCAD's going to understand, okay, I don't want to go in the positive direction. I probably want to go in the other direction. So it automatically updates this number to 1 in the other direction. And I want to make it a little bit longer for the OD. Let's go 4 inches. That's a little much. Let's go 3 inches. And then I'm going to scroll down and click OK. So here's what we've got so far. I created the drawing of a hex from the shape library of the default numbers. I created a circle right here for the OD at the CAD origin location as well, with a diameter of 3 inches. Then I did an extrude boss of the hex in the positive direction of 1 inch. And then I did an extrude boss in the other direction of 3 inches. And so that we can double check our work, I'm going to go to the top. I'm going to go to evaluate. I'm going to go to measure 1. And I'm going to pick the solid. So I have to check this box and then click the solid. It will give me the area and volume. So if you have a surface area of 48.5078 and a volume of this 3D model of 23.809, then you've got it correct. If not, you can always go back in the video here and review your work here to create the 3D model. I'm going to move this over here. All right, see if you guys have any questions, comments, concerns so far. But yeah, we've just got the basic shape here. We're going to be turning down the stock. We'll actually be doing a facing operation in the mill turn functionality. In the turning, we're going to be doing a facing operation with a turning tool, and then we're going to be using a turning tool to turn down the OD as much as we can here with the hex, and I'm going to turn down the OD as well, and then we'll be using a milling tool to go around the outside here. I think in CAD I want to do a little bit more. Let's do some drilling operations on the front here, in between the hex and the OD, like on the side. If you can see my cursor, I'm going to do 2 holes on the sides as well. I'm thinking about doing a pocket on the side as well, so that we can create that pocket here also in CAD, so we can see how that looks. Let's do that. So I'm going to go to Create 2D. I'm going to go to Arc, and I'm going to change the diameter. Let's do a 1/4 inch diameter for the holes. And we are going in the X position. I'm going to move it over -1.5. I'm right on the edge of the OD, so I need to pull it back a little bit. Let's do -1.25 and then hit OK. And then I'm going to just get rid of that negative number, so I'm at 1.25 on the other side of the part as well, and click OK. And then cancel out of that arc function to create my holes. Then we want to, now this is more for like 4 or 5 axis mill turn programming to do a pocket on the side of the OD here, but we'll do that as well, get into that a little bit later. But we do need to make it in CAD. So first I'm going to make the holes in 3D instead of just having them as circles in wireframe. So I'm going to go to Create 3D. I'm going to go to Extrude Cut. I'm going to hide the solid for a second so I can see the wireframe of the holes, so that I can click on them a little more easily than picking the surface here. I'm going to hit S on my keyboard, S for solid, and it's going to show or hide the solid depending on when I hit S on my keyboard. A couple other shortcut keys that are really nice are T for transparent, so that you can see the holes once they're created and see the depth of them. W for wireframe, shows you the wireframe of the 3D model, I suppose, like the cross section of it. I never really use W for wireframe, but I very frequently use T for transparent and S for solid. And I also use all of the basic Windows functions a lot too. The Control C to copy, Control V to paste, Control Z to undo, Control Y to redo. You have your undo and redo up at the top of the software program as well, but those Microsoft or Windows function shortcut functions are very useful there. So anyways, we're in the extrude cut. I selected the 2 holes. I'm going to go in the other direction. Let's go 1 inch. And then I'll scroll down and click OK. So we got 1/4 inch holes at 1 inch depth on the sides there. And now I want to make a pocket. It's going to be a little difficult because it's on the side here, and it's not as if I was drawing the pocket in a top view here. So I think the easiest way, we went through this in the CAD webinar 2 weeks ago, a really great webinar that you guys may want to watch if you're having trouble with the 3D modeling portion of it here in BobCAD. We went on different UCS planes and created pockets and solids, bosses, and things like that on different UCSs, on different user coordinate systems. I'm actually going to do that here really quickly. Down at the bottom right corner, which is where I am taking up space. So I'm going to move myself real quick. All right, so down at the bottom left corner here, we have layers, UCS, and posting. So I'm going to click on UCS. We've got our top UCS or a top plane that we're sketching on in X and Y. We've got a front plane and we've got a side plane. Now I suppose I could go on the front plane here and just make a pocket over here on the side of the OD, but I can also make a plane right at the top of the cylinder very easily by right-clicking over here in the UCS manager and going to Add New UCS. We've got a bunch of different options here at the top for our creation option. First, I'll name it if I want to. I'm just going to leave it not named as my name. I've got different options here for creating the plane or the UCS, selecting a snap point for my new UCS, just clicking a point, and it basically references the original top UCS and just translates it to that point. 3 points where I can click on my point as my origin, click on a point or a line as my X direction, and click on a point or a line for my Y direction. Translate, so I'm just translating the UCS over. Planar face would be if I had a flat surface like this for my new UCS. And the last one down, second to last one, cylindrical face, where I can select a cylindrical surface. It selects the end of it there. I don't necessarily care for that. I can also rotate my original UCS in these creation options. So I thought the cylindrical face would go right on the OD on the top here, but maybe not. I could modify it, but I think the easiest way would be canceling out of the UCS and simply just using the front. Where am I? There we go. Instead of using a top UCS on the top here, using the front UCS. And so I'm just gonna sort of create a square in the cross section of it here. So I'm in a front UCS. I go to the top, go to create 2D, and go to rectangle. And I'm just simply creating a rectangular pocket. And this is, let's see, in relation to the top view, we want to move it over in, or move it down in Z, it looks like. Let's try down in Z. All right, how about now, guys? Can you guys hear me? My headset doesn't like to work with me very well. Let me know if you guys can hear me through the audio here, just straight through the computer microphone, and we'll keep going along with it. And what I did was I created just to recap, I created the hex and did an extrude boss. Awesome. Thank you, guys. Thanks for letting me know that you can hear me now with the audio. So yeah, just to recap, I created the hex and did an extrude boss. I created the OD of a diameter of 3 inches for the circle, created another extrude boss of 3 inches down, 1 inch up for the hex here, 2 holes on the sides to drill out with live tooling, because we're not on the center line of rotation. And we're also going to be using live tooling for the hex and also for the pocket on the side here of the part. It's going to be difficult. Well, I'm going to add more stock here so that we can turn down the stock to here and be able to fit the tool into the pocket here. So let's get started with the CAM side of things. We're going to go to the top and we're going to go to CAM and we're going to go to a new job. We're going to go to, let's see, it's instead of milling and instead of turning, we've got mill turn. So again, that's a lathe with live tooling. So we'll be doing our turning and our milling operations in this job type. And then we're going to be selecting our machine, BC1T1S. That stands for BobCAD. So it's one of our generic BobCAD machines with a Fanuc-based G-code format for all of these BobCAD machines. And 1T stands for one turret, 1S stands for one spindle. If you also have a sub-spindle, we've got this one, BC1T2S. If your machine is able to move in the Y-axis, that's what this Y-axis machine is for, 2 turret, 2 spindle, and 2 turret, 2 spindle with 5-axis. You can see some of these in here as well that I had downloaded for customers. We support Haas mill turn machines, Mazak, Kia, Super Turn with Fanuc controller, plenty of other machines that we have worked with customers with. These are just the ones I've worked with in tech support and training. But yeah, so if you guys have a machine with mill turn, we have that machine checklist for you to fill out and send to us to make sure there's no crashing at the machine, no collisions or anything like that. And here, so I go to Stock Wizard. After I select my machine, I define my workpiece, which is this 3D model, and then go to the next page. And then I define my stock. It's going to be a cylindrical stock type, so I'm going to change it from rectangle to cylinder. Hit calculate, and it's extruding out through the Z-axis for my extrusion direction here. And then our last page is our machine setup. This is very necessary to change because I had drawn and 3D modeled my mill turn part any which way I wanted to, but we need our Z and X coordinates, our lathe coordinates, correct for the machining process. You can model it however you want to in your global coordinate system with CAD, but with the machine setup, you want it done correctly for the G-code formatting. So with the machine setup 1, first I'm going to highlight this box under origin. I'm going to click on the front face of the stock, our Z-axis going out, and our X-axis pointed up. So really all I have to do is scroll down, highlight X direction, and click on this point at the top for my X direction here. All right, cool. So now I'm going to scroll down and click OK. I've got everything figured out the way I want. The only thing I want to change is I want to add a little bit to the face to face off, and I want to add a little bit on the back end and on the OD. So I'm gonna go back into my stock wizard. So I'm gonna right click on stock. I'm gonna go to stock wizard. I'm going to, let's see, I'm really just gonna add an offset for my OD. Let's add an extra 1/2 inch. For my start face, let's add 100 thousandths. And for my end face, let's add an extra inch there so that we can have something to grab onto. Then my last page here, I go to my next page again for my machine setup. Usually we'll, click on origin and click on the front face of the stock so that we're starting right at the front face there instead of the extra 100 thou back. And then I'm going to scroll down to the very bottom and we have this work offset XYZ. So I'm going to, this is for simulation purposes. My stock, if I look at it on the stock wizard, is a height of 4 with an extra 1.1. So that's 5.1 for my stock length there. On my machine setup, this work offset is in relation to the front of the spindle. So if we want to offset it for the jaws that are going to be clamping on to the part, we want to change the work offset in Z of at least 5.1 here. I'm going to do 5.2. So that should have an extra 100 thou on the back end for the jaws to clamp down on. Again, this is for simulation purposes only, so that we can see the stock outside of the jaws when we look at simulation. If it's only changing the simulation, it's not going to be changing anything in the G code with these numbers here under work offset XYZ. Awesome. So now I will click OK. I would normally save the part file from here. I would probably save it a lot sooner than this, but this is just a sample file for our webinar today. So then we go to the stock wizard. We see everything there in the stock wizard is correct. I can change the color of the stock. I can change the transparency if I want it lighter, and I can also blank or unblank it to show or hide the stock at any time. And then below that is our machine setup. If we need to change the work offset location, I can also right click on it, and this is where we have all of our operations for programming to turn down the stock and then do our milling operations. So first I'm going to go to turn features, and these are all of the same turning features as in the lathe portion of the software program. All right, so we've got facing, turning on the ID or the OD of the part, groove, drilling, tapping, threading, cutoff, and stock handling for a bar feeder. And so what I'm going to be doing is I'm going to be doing the facing operation first. So I'm going to select lathe and face, select my geometry, and for the facing, I could click a point like this, I believe, or an edge. So let me click on anything. Oh, there we go. So it'll let me click on a surface edge or a point or a line in the Z and X axis to be able to do my facing operation. I select the rapid plane, so it'll rapid to 200 thou above the stock, and then either region 1, so it's going down, or region 2, where it's starting from the center point of rotation and working my way up. From stock or custom, we'll get into that in the next turning operation. We can do a rough operation and then a finish pass. We can now put in separate moves or in can cycles. We can define our tool insert and our tool holder on the next page. So it's really important to create your geometry in the tool crib. And on this page, you can output your feeds and speeds, your spindle RPM, and you could output the feeds and speeds in RPM or in constant surface speed here. And then after that, we'll mount the tool onto our turret by clicking on tool crib. And here's our turret with the different station numbers over on the left-hand side. And if it's less than or more than the station numbers here, you can go to the turret wizard and you can change everything along with the turret, the station numbers, and and adapters and things like that you can import to model it exactly how it looks on the machine to avoid any collisions with the tool, any tools on the turret, and anything else on the machine there. Now you can see the tool starts in this loose category. I want to drag and drop it into any of these station numbers. So I'm going to start with station number 1 here. I'm going to drag it from the loose category into station number 1. I can click and hold with my left mouse button to rotate it around. I think I can zoom in. Yeah, I can zoom in and out with the scroll wheel to see it exactly where it is. And then I can move. I want to move it down because here's the tool tip, but I want to move it down out of the turret a little bit. So that's what the shift option is for over on the right-hand side. I'm going to shift it down in the X direction here. So I'm going to go here to X, and I'm going to put -2. Looks pretty stubby still, so I'm going to change it to -4. And you can change the mounting orientation here as well, if it's a left-hand or a right-hand tool, or if it's any of the other mounting orientations here, of any of the 8 different sides that we can support here. And then I click OK. And then I go to my next page. Compensation. We can turn on the compensation for the tool, and we can also turn on collision detection. If we have it off, the tool or tool holder could be gouging into the stock if it drops down too quickly. We want to turn on collision detection to avoid that. That way it's going to leave some area here, but then we can use a finish tool to finish that up. What next? We go to our next page. We go to our depth of cut options. I'm going to do 20 thou. Page where the tool is going to wrap it from, where it will wrap it back after the operation is finished. We can set our lead in and our lead outs from here. Advanced feed rates. If I'm not able to set the rapid rate at the controller, I can change the rapid moves to feed moves, so I can control that rate. And I can also control the feed rate for my lead in and my lead out here specifically. Last page here is MDI. That stands for manual data input. If I wanted to add any miscellaneous G or M codes before or after the operation, I can do that here. You can see all the different options that we offer in mill turn. We offer a part transfer from the main spindle to the sub spindle. We offer a part catcher, and all of these other G and M codes that we can output for a tail stock and things like that for the lathe. Then we go to our next page. I'm going to use the same tool for my finish pass, and same kinds of options as before, turning on collision detection. With our finish pass, we can do a continuous pass. We can alternate back and forth between vertical and horizontal cutting, and or we can face the vertical only or turn the diameter only. So different options like that for our finish pass. I'm just going to do a continuous finish pass. This is just for facing anyway. Next, we've got our parameters. We had a finish allowance of 10 thou on the floors and the sidewalls for the finish pass to clean up. This is the allowance. On our finish pass, we're leaving it at 0 so that we're finishing up the face here. Rapids, leads, advanced feed rates, and MDI, just like for our roughing. So after all of those pages are done, we're going to hit compute down at the bottom right-hand corner here. I think it takes a few seconds to calculate the collision detection. Make sure that there's no collisions between the tool and the stock. You can see all of these different passes, 20 thou, roughing every time there to get to our 100 thou there. And then we're going to get into turning down the OD of the stock with this hex and this out to here. Then we'll do the live tooling options. So again, I right click on machine setup 1, go to turn features, go to lathe turning. Now here's one issue, selecting my geometry. I don't have the wireframe. I don't think that'll work, but I'm really curious now. No, it'll actually work with a surface edge like that, but it doesn't work with the surface of the cylinder. So we can easily create the wireframe from a solid model like this in BobCAD. I'm going to go to my layers over on the bottom right here. I'm going to right click and add a new layer. And it's active with that green check mark. So when I'm creating a sketch, it's going to be created on that layer versus the CAD layer where my 3D model and all of my sketching has been done. I'm going to go to the top. I'm going to go to create 2D. And I'm going to go here to spun profile. All I have to do is select the surfaces of the solid and click OK. Now it created the wireframe, not exactly what I wanted because it's not along the correct axis. So I'm going to hit undo and I'm going to select the surfaces again. I think it's going to be around the z-axis. So I change it from a long x-axis to z-axis and click OK and then hide the CAD layer. Yeah, that's really what I wanted there. I really wanted it, more faced to where it is with my toolpath, but I think this will do anyway. We could rotate it around 90 degrees, but I think this works for us. Let's test it out. We go to our CAM tree, right click on Machine Setup 1 again, and go to Turn Features, Lathe Turning. Select Geometry. I'm going to select these 3 lines right here for turning down the OD. Next page, we're turning down the OD rather than the ID with like a boring cycle. We also have the options of front face and back face. So front face will start from the top and sort of do a facing operation to rough it out like that, or back face. We want OD, so we're just going horizontally across to turn down the stock. Then we have our constraints. This is from stock, so from our original stock, BobCAD will do all of the roughing and finish pass from the original stock to our wireframe we selected. From geometry would be if we had already turned down the stock at the top, we could start right from there. If we've already faced it like this, we can do it from there. And then custom. So if we had already turned down a certain amount from here to here, we can tell the software where we're starting from to avoid any air cutting. So that's what these constrained options are for. If we want to start a little bit further from the face right here and then end a little bit further back, we have these extension options here as well. Next page, we're going to do a rough pattern and then a basic finish pass. We can now put in separate moves or in can cycles for all of our turning operations. Save you a lot of G-code output there. Next, we've got tool number 1. Going to stick with the same tool. Turn on with collision detection. Use tool holder. And same kinds of options as before. I'm just going to leave it at a 50 thou depth of cut. Leave 10 thou on the sidewall in the finish pass to clean up with my finish pass here. And then same options, rapids, leads, advanced feed rate, and MDI. Same tool for my roughing and finish pass here for the OD. Turn on system compensation with collision detection. Finish allowance of 0, rapids, leads, advanced feed rates, and MDI. I'm going to hit compute. And that didn't work for us because it's not in the same location here for my drawing. So I do have to rotate it around 90 degrees. I'm going to go to Utilities and go to Rotate. Select my drawing here. I'm going to rotate it -90 in Z. And it's from the origin location of X0, Y0, Z0. And I'm going to scroll down and click OK. So it's still, in that location that I need there. Now that I've rotated it, I'm going to go back to the CAM tree, select my geometry as these 3 lines, click OK, and then compute the toolpath again. And let's see how it looks. Yep, that looks correct now. Thank you guys for bearing with me with the sort of discrepancies of having to rotate the wireframe after using the spun profile and anything else that we may run into. I am starting from scratch with this 3D model. So if you guys are just entering the live event today, you can go back to it at any time after the live event is over and be able to see how I created the hex, extruded it out, created the OD and extruded that out, did an extrude cut for the holes and the pocket that we're going to be going over next. All right, cool. So we've got the facing operation, then we've got the turning operation on the OD. I can take a look at any of these operations by right-clicking. I'm going to right-click on Basic Finish at the bottom here, and I'm going to go to Backplot. And what that will do is it will show me the tool and backplot it. I can either press play or hit next to skip through step by step and just step through the toolpath here for the tool. Instead of having to go in simulation every time, viewing it, backing out, and viewing it every time, we do have a backplot option to quickly see the toolpath and the stepping through with the backplot. So next, we're going to get into live tooling. I'm going to right-click on Machine Setup 1, go to Mill Features, and you can see our drilling, tapping, counterbore options, just like in the milling functionality of BobCAD. I'm going to go to Mill 2-axis. I'm going to select my geometry. I'm going to select the surface edges right here to make things easy for me. You could also hide the solid and pick the wireframe that we started with the hex with, or that's about it. That way you could chain select the wireframe, but I'm just individually selecting those 6 surface edges. I'm going to scroll down, and I'm going to pick my top of feature. So I'm starting at this edge right here, and then I'm picking the bottom of my feature, which is at the bottom of the hex right here. There we go. And then I'm going to click OK. Next page, we have our top of feature, total depth. I'm starting 100 thou below the work offset because we faced 100 thou off of the front face of the stock. And we have our total depth of 1 inch. We're doing a profile rough and a profile finish pass. We have options for tabs, really not getting into that for lathe. We have some posting options. You can set a work offset number. Over here, you have your sub-machine. UT stands for upper turret. MS stands for main spindle. So if you had 2 turrets on the machine, you've got your upper turret, and then you've got LT for lower turret. For spindles, MS would be for main spindle. If you have a sub spindle right here, would be SS that you could select to program for. Then you've got your posting mode. We're going to start with auto Y-axis mode. So that is going, that one and the longhand code. No, I think auto Y-axis mode, I think will have the Y-axis movement if your machine is programmed set up for Y-axis movement. You have longhand code, which is step-by-step of moving across with the milling tool, and polar interpolation. We're able to support that as well. So I'm just going to stick with Y-axis mode to start with. We can change these around to see the difference in G-code afterward. Multi-axis post, if you need to change anything in here. I really don't touch this at all. I let the post-processor department work on this if we need to change anything in here. Then we get to our tool page. So for the milling tool, again, I go to the tool crib, and I mount my milling tool onto the station number here. Let's skip a few and go to station number 4. So we have station 1 here with the turning tool. We've got station number 4 here with the milling tool. And looks like I don't really have to move it over at all. Down here, you can add from your adapter library first to add an adapter for the milling tool, and then you can move it over by shifting it over out of the adapter if you've added one. Then I'm going to click OK. I can set my feed rate here. I can go to my next page. I have my different cut patterns. So standard will just do 1 pass with my roughing. Contour ramping would do a helical ramp down into the material the whole time for passing around it. And we also have side roughing. So I can do multiple passes and work my way in to rough out everything that I need from the cylinder. So I'm going to set a step over. Let's see, my tool is a 1/2 inch. I'm going to do a step over of a 1/4 inch. And number of passes, I'm going to start with 4. I might need a few more passes, but that's what I'm going to start with. System compensation, I'm going to leave as left and go to my next page. Side allowance, I'll leave as 10 thou. I think by default normally is 15 thou. I set it as a default of 10 thou by just going to the bottom here and saving that as a default number for my profile roughing. Just to show you, there is a save defaults button for every turning operation and for every milling operation, so you don't have to change your default numbers in here every time. I'm also going to change this option from single step to multiple steps, and we'll do a 1/4 inch depth of cut as well. So 1/4 inch depth of cut, a 1/4 inch step over every time. It's a very large amount of material to be cutting at a time, but this is what we're starting with. And we'll go to our next page, and we have options for a lead in and a lead out. I'm going to go with a parallel lead in and lead out so that we're not starting right on the material as we plunge in there. Go to our next page, corner types, machine sequence, advanced feed rates, and MDI. Those are all of the basic options that we have for milling, just like before. If you guys have any questions with these options here, please let me know. More than happy to answer any more questions that you guys have. With that, I go to my tool page for the finish operation, and I'm just going to select that same 1/2 inch flat rough end mill. And that's considered tool number 4 because it's in station number 4. So I've only got one tool for the facing and turning, one tool for the roughing and finishing around the hex here. That's in station number 4. After that, same kinds of options as the roughing, setting our compensation on the left or the right side of the path, giving us our climb mill or conventional milling options. I'm only doing one single pass for the finish pass at the full 1 inch depth. I'm going to do a parallel lead in and lead out again, so I'm not plunging right onto the material. Then again, our corner types and machine sequence, advanced feed rates, and MDI. Then I'll hit compute. Now you'll see the toolpath is inside of the 3D model. And the reason for that is the direction of the cut. So it's compensating on the left side of the path, and it's cutting. If I highlight default chain start point, it's highlighting, or it's going in the direction of counterclockwise. So if it goes counterclockwise in this direction and offsets on the left, let's look at the arrow here. It's cutting counterclockwise. And if it compensates on the left, it's compensating on the inside. So I could either change it from left to right, or I can change the direction of the cut from counterclockwise to clockwise, which is what I'll do, by right-clicking on default chain start point, clicking on reverse direction. You'll see the arrow change from counterclockwise to clockwise. I right-click on the feature and hit compute. I'm going to look at it from a top view. It looks like there's a lot of air cutting with that. I mean, it's all air cutting with that first pass. There's a little bit of cutting with the second one. So I'm going to eliminate the first 2 here. I'm going to edit the feature that I just created for milling. I'm going to go to my I'm going to go to my patterns page under profile rough. And I'm going to change the number of passes from 4 to 2. There we go. Should look a lot better in simulation. So we have got our facing. We'll take a look at all the toolpath here. We have got our facing operation with our turning tool. We've got the turning of the OD with our turning tool as well, still in station number 1. And then we've got the milling operation that we're doing here around the hex. Now, Next, we'll be drilling these 2 holes on the from the hex into that cylindrical shape, and then we'll be indexing onto this side and pocketing this. I don't think I'll be able to do this if I don't have y-axis movement, but that's okay. We'll still program for it. We can see it in backplot. We might have to change our machine to program for that. But yeah, I've done a whole lot of programming. Haven't saved it in quite a while, so I'm going to save it. I normally save it every couple of minutes to make sure there's no crashing or, sometimes I forget to plug in my laptop and get it to charge. So I frequently will save to make sure that there's no issues with that. So, and if there's any questions, please let me know in the comments section. More than happy to help with anything that you've run into with drawing, 3D modeling, and programming with the toolpath in MillTurn here. So we've done facing, we've done turning on the OD, we've done the hex. Now we've gotten to this depth to be able to do the 2 holes to drill those out on the sides here. I'm going to do that by right-clicking on Machine Setup 1, going to Mill Features, and going to Mill Drill Hole. I'm going to select my geometry. You can select the wireframe of the holes that we created as a 1/4 inch diameter arc. You can select the surface edges right here. What I normally do is, if I've got the 3D model, I will select the sleeves of the holes here so that I can use as top or use as bottom. I'm going to use as top to be able to have BobCAD recognize the top of the hole that we're starting at. And then I also want to make sure to pick bottom and pick the depth. So I'm going to hit S on my keyboard again to hide the solid and pick that bottom surface edge so that it picks up the total depth for me that I need of 1 inch. It is not a through hole, so I'll uncheck that box. Next page, it gives me the top of feature, which we're starting 1.1 inches from the work offset and going down a total of 1 inch for our depth. Next page, I'm just going to do a drill operation. I'm not going to use a center drill. I'm just going to use the drill. So what I normally do is I click on hole. It brings in center drill and drill under my current operations. I'm going to highlight center drill, delete that out. We'll just do a drill on one side, retract, and go to the next location. Sorting order, most optimized way for the 2 holes. We can post out in y-axis mode or in longhand mode. We can define the tool and the dwell time, plunge feed rate. You can see every time we have a tool number here, it normally starts at -1. And the reason why is because we don't have it mounted in the station number yet. So I always see that -1. It always reminds me, okay, go to the tool crib, go from the loose category, and let's put it in station number 8 and click OK. Then our last 2 pages, setting up the parameters. If I want to do a pecking operation for drilling, I always make a side note with V37, we now have peck tapping already in the software program. So you go to tapping, you'll see the pecking option in there as well. And then our last page, MDI for manual data input. Just going to hit compute, and I'll see the toolpath inside of the solid from there. We've got a question. Brian said, how do you delete the loose tool in the crib? That's a good question. I think you can just right click. So I'm just going to right click on the last feature I made for drilling, go to edit. I'm going to go to the tool page, which is drill here. Go to the tool crib. And if there was a tool in the loose category, let's try it for center drill. Just for fun here, let's go to machining strategy. I'm going to go to center drill, add that in, move it to the top. Go to the center drill page, go to tool crib. It's in the loose category. Let's right click. We have change tool, edit tool, mount and remove tool holder. So I think I should be able to do a center drill with the drill that I've just created in station number 8. So when you have selected, how do I phrase this? When you have selected all turning and milling operations without the loose category, then the tool in the loose category goes away. So let me try that with this one. If I highlight 1/4 inch drill and click OK, nope, incorrect tool type selected. So let me, sorry, I'm bouncing around here back and forth. So what I'm going to do is I'm going to get rid of center drill here. Let's add another drill operation in this feature. So we've got tool number 8 with our 1/4 inch drill for the first drilling operation. Then for the second drilling operation, I'm going to go to my tool crib. There's still no loose category. Let me get rid of that one. So we've just got the one drill in here now and hit compute. It did it for my profiling. It had a rough and a finished tool. Got rid of the finished tool in the loose tool category. So we'll actually see that in the pocket and profile finish here on the OD. So bear with me for a second. I'll show you that next. I'm going to save the part file. Then I'm going to go to setting up the pocket operation right here. I'm going to do that. First, I have to create an index. The reason for that is because when I'm doing a profile like this here, profile rough and finish, the tool is pointed to the Z axis that I've set for my work offset. So to rotate it 90 degrees to do a pocket and profile on this side, I have to first right click on machine setup 1. I have to go to additional functions and go to add index. I have to pick a surface for my new Z-axis that's highlighted there in red. So I clicked on that surface. Sometimes the arrow is going inside of the part. We don't want that. We want it the opposite direction. So if it is going in that direction, you want to click reverse for the positive Z-axis to be normal to that surface. And then we click OK. Scroll down to the very bottom where we have our new index system, and I program from there. I right click on index system. I go to mill 2 axis, select my geometry. I'm going to select these 4 edges inside of the pocket here. I could also click on the wireframe at the top there, but I usually pick the surface edges because then I know that's my depth that I want. So when I scroll down and I click pick top, I'm picking the top of the OD right here of the part file. And then pick bottom, I'm picking the bottom depth of a 1/2 inch here. Then I click OK. Next page, got our total depth as I have already set. Next page, we're going to be doing pocketing here. So we'll have a pocket and then a profile finish. Next page, we have options for tabs. Then we have our posting options here. And then we get to our rough tool of tool number 4 from station number 4. I'm going to leave it as that 1/2 inch flat end mill. Go into my tool crib. We can see it here in the station number 4. Next page, we have our cut patterns for pocketing. We could do a parallel, zigzag back and forth inside of the pocket, pocket from the center, work our way out, start from the sidewalls, work our way to the center of the pocket, and then we have our high-speed machining options with morph spiral and adaptive roughing so that it will keep constant tool engagement with these cut patterns. Next, side allowance, we're leaving 10 thou on the sidewalls for the finish pass to clean up. Let's go down to the bottom here for multiple steps, and we'll do a depth of cut of 1/4 inch for each depth there. Entry options, machine sequence, links, advanced feed rates, and MDI page. Now, we've gotten to the finish tool category for the profile finish pass. And if you see here, we've got tool number says -1. So this one's going to be in our loose category. So I did it really quickly in the profile rough and profile finish. I actually didn't mention it. So thank you, Brian, for mentioning that question. How do you delete this tool in the loose category to use a different tool that's already in there? I go to the top, go to tool crib, and you can see here it's a 1/2" flat end mill under loose. If I want to use a different tool in station number already, I simply just click on that tool. So let's say I want to use the profile finish pass with a 1/2" rough end mill like I have in station number 4. I just click and highlight that tool, and you'll see it's still in the loose category. But once I click and highlight this tool under station number 4 and click OK, the tool in the loose category will go away once I go back to the tool crib. So easy way to get rid of the tool in the loose category is selecting one of the tools already in the station numbers here, or I can just simply drag and drop the tool if I'm using that one from the loose category into any of the station numbers. So now we're at tool number 4 for the profile finish. We've got our compensation for the profile pass inside the pocket. 1 pass at a total depth of a 1/2". Lead in, lead out options, corner types, machine sequence, advanced feed rates, and MDI. I'm going to hit compute. We can see the pocket inside right here. We can backplot it. I'm going to right click on the pocket here and click on backplot. Yeah, no problem, Brian. Let me know if you guys have any more questions going through here. So we've got the pocket here on the side of the OD. I'm just going to step through and see the, it's plunging down to start with, going around. Realistically, I probably wouldn't plunge down with an end mill for the pocket here. I would probably, either do a zigzag or a spiral helical interpolation down into the stock to start with, or if I had enough room, I could start from the outside of the stock, work my way into the OD like that here. Different options like that. But this is a good backplot to see the tool is kicked 90 degrees from the original Z-axis, coming down and pocketing this area out, and then doing a profile finish pass inside of the pocket here. We'll close out of backplot. And let's try simulation. I don't think the machine is set up for this pocket, but let's try. I'll click on Start Simulation. And it gives me an error. It says that my machine limits are reached in the X-axis for that 2-axis profile rough that I did. I don't have enough machine limit for the original profile, I believe. Let me turn off the index system and try to simulate. Yeah, it doesn't like the profile rough of the helix as well, or the hex as well. It says it doesn't like it in the X direction. I'm just going to turn that off for now. We can take a look at our simulation for a second. Now, if you have mill turn unlocked on your software program, you'll be able to view the machine here in mill turn. You'll also be able to view any of your milling machines as well. It can be really helpful if you've got a rotary table or if you've got a 5-axis with a trunnion. You'll be able to model it here in the BobCAD simulation, make sure there's no collisions and the rotation's correct by going to the top here. Under simulation, you've got workpiece stock. Normally, you can drop this down and click on machine. And it brings in your machine here. This is the BobCAD 1 turret, 1 spindle machine. Very basic, but really cool to be able to see all the tools and the station numbers of your turret. you can see that I've moved out the stock, that 5.2 inches, I believe. From the front face here, that was that work offset XYZ to be able to get it out of the chuck. And then I can slow down my simulation run speed at the top here and then hit run. So here is the facing operation. Roughing and then finishing. Here is the turning of the OD. So it looks like, based on the stock, I haven't moved it out far enough yet, but great simulation to see all of that being done. Next will be the drilling, and that's it. I don't know what's going on with the hex. But whenever you get that error, we've also got a retract issue there as well. So let's fix this retract issue. Let's change the limits to be able to output for the hex operation. And also, if we have enough time, we'll change the machine as well to be able to simulate the pocket on the side of the part as well. So I'm going to close out of simulation. Let's fix that retract issue first. So you can see the retract is right here, going across for the drill operation. I think the reason for that is because of our top of feature is starting here. BobCAD didn't understand that there is a boss in between them. So let's go to feature mill hole, edit that. We're just going to change my top of feature to 0. My depth of 1 inch. Well, I don't think so. So let's actually just play it safe that I normally do, is we click pick top, and I'm just going to pick the top here of the boss, and then my depth, I'm going to pick the bottom of the hole. So feature depth will be 2 inches. And then I'm going to click compute. Now we have plenty of room to get rid of that collision there between the boss. Save what I have so far. Figure out what's going on with the hex is going to be the machine limits. Now, before I go to the machine limits, let me answer any questions you guys have. Brian asked, how is the tool crib shelf used? Shelf. Tool crib. Oh, shelf. Gotcha. So the shelf is kind of like the tool crib in milling and in lathe. You've got like a shorthand list of other tools that you could import right into here to be able to have it sort of as a loose category, but BobCAD doesn't like any tools that are in the loose category. If you had tools in the loose category and try to simulate or post it, I think even compute, it's going to give you an error saying, hey, there's still tools in the loose category that you may want to put in a station. So instead of having them in the loose category, you can have them in the shelf category, and you'd be able to sort of, I believe, drag and drop them in. Actually, maybe not. It might not be from the tool crib. You can delete them here. But what you can do, I know that you can go to the, what I would probably do is go to the CAM tab up at the top, go to Tool Library, and then in Mill Turn, you can go to here and set up the tools in the shelf so that you have, it's sort of like a tool crib, like in milling and lathe, to be able to drag and drop them in to the station numbers whenever you need to use them. But other than that, we're going to change the limits to the machine. So I'm going to scroll up. I'm going to go to right-click on CAM defaults in the CAM tree and go to current settings. I'm going to select my machine that I'm using here. It's my BobCAD 1 turret, 1 spindle machine. Go to machine definition, which is the next one down, And here's where you can add a rotational axis. You can change the limits to a rotational axis and also change the limits to a linear axis as well. Now, I really don't recommend customers changing these numbers. I recommend contacting us first, getting with our post-processor department, because all of these numbers are saved with our information as well. So when we, work on tech support, work on a post processor, we want to make sure that these numbers are on your side the same numbers as on our side. So I don't recommend changing these numbers. I'm just going to change them just to show you if you needed to change them for whatever reason. You need to get something out the door and it's giving you an error to where you can't simulate or post the G code because of an over travel limit. You can easily change it on the fly here if it's necessary. So we have our C-axis rotation. We have our Z-axis limits here. You can see when I highlight Z down here, over on the right-hand side, we have minimum and maximum. So minimum Z limit is -40 and maximum is a +400. Go to Y, we have +, -5. I'm almost sure this is in inches, as long as you have it in inches down at the bottom right corner of your software program. But when you get errors of an over travel, then that always comes up in millimeters. But here you can set it up in inch. Let's see, x-axis, we've got +, -30. So let me just try, I'm going to try +, -100. I'm like 99% sure it's set an X over travel limit. I click OK, and it asks me if it wants to make the changes to the milling job I'm in. Yes. And then let's take a look at the simulation from here. Oh wait, I have to turn on the profile rough and finish first. No, still an issue for travel in X. Minimum is 0. It should do it for me pretty easily, unless I could change the posting. It might not like y-axis mode. Let's try that. There we go. Perfect. So all I did was I went into the feature, went to the posting page, and instead of auto y-axis mode, this machine isn't set up for that. I changed it to longhand code. And then I hit compute. So you'll see in simulation, really cool with the milling operation for profiling, it is going to move back and forth in X, and the part's going to rotate in the C-axis to give us the profile around the part. So here it's facing with the turning tool, then turning down the OD with the turning tool. Then it will do our milling operation around the hex. Here comes the milling tool, coming down in X. Now I've already turned down this stock, so there's some air cutting still. I would want to eliminate that first pass that I did with the side roughing to eliminate this air cutting of this pass around here. It's actually going to do 4 of them, I believe. Oh, there we go. So then it goes in and does the roughing. You can see a lot of air cutting at each depth there. And then the finish pass, and then drilling the 2 holes on each side and making sure it comes out far enough for the boss to not collide into that. So I'll close out of simulation. I'm going to eliminate these first passes over here with milling to eliminate that air cutting. Save us some time with that by right-clicking on the feature 2 axis for the profile rough and finish, edit that, go to patterns, and looks like I only have to do one. Then I will save my progress. Everything should be good up until the pocket. Let me turn on the pocket and then start simulation. It says current toolpath is not for 4-axis machine. Posting process exception. So what I would have to do is change the, oh wait, I need to change the tool too, I think. Yeah, so I need to change the tool because the tool isn't orientated correctly. And I think I also need to change the machine. But let's start with the tool. Let's see if that will fix the problem. So I'll right click on the bottom feature 2 axis, go to edit, go to my tool page, and it can't be tool number 4 because that's already orientated to point towards the front face of the stock. I'm going to go to my tool crib. I'm going to actually have to click on loose category, or I could click on any station number that I want to add it into. I'm going to start with loose. No, actually, it won't let me. So let's go to station number 10, add from tool library, sort by diameter up at the top here. And I'm going to use another 1/2 inch flat end mill and click OK. And it's in station number 10. And I have to change the mounting orientation from 1 to 2. And you can see it's a little stubby still inside of the turret. So I'm going to shift it down in X. Let's move it down 2 inches. And now it's floating in space. I'm a little particular with that. When I see it in simulation, it doesn't look very realistic. So I'm going to change it to -1. Cool. Looks as good as it's going to get now without adding in my adapters just yet. So I'm going to click OK. I'm going to go to the tool page for my profile finish and make sure I have it as tool number 10 as well. Awesome. Thank you, Brian, for viewing the live event today. And thank you, everybody else, for viewing it today. I'm glad you guys are able to keep up with me. I know there's a lot of ins and outs because I have started from scratch with the drawing in the 3D model and programming all of this from scratch, just to give you guys a better understanding of the mill turn package here. So again, we've got this tool as tool number 10, the correct mounting orientation. I hit compute. The toolpath looks good. The backplot's going to look good too. I just want to make sure that simulation will work correctly for us based on the machine I have selected as my BobCAD, 1 turret, 1 spindle machine. It actually works for us. Cool. Sometimes some machines don't have the right movement to be able to move in X and Y to do the pocket here. Yeah, looks good. Okay, so I'll start my simulation. I don't think I have the stock sticking out far enough to do the pocket, but we'll take a look at it either way. If we need to move it out after, we can definitely do that. Don't have enough room for the didn't have enough room for the turning on the OD, so we'll move it out for that at least. We've got the profile rough, the profile finish, the drill of the 2 holes, and then it comes in on the side. Tries to pocket and profile finish on the side here, but it's running into the jaws, and it will it'll cut all of that out. But yeah, this is a good thing for simulation to see. If we want to make sure everything looks good, we want to move it out. Let's see, that's at least a 1/2 inch because of the tool. So we'll go another inch. We'll close out of simulation. We'll right click on machine setup 1 and edit. We'll scroll down to the bottom and we will change this to 6.2. Start simulation. This is looking better. What I can do is I can hit next op up at the top so that I can skip through the turning operations. We just squeaked by with the turning of the OD there. And we should be good on our pocket and profile finish pass. We've got the profile around the hex, we've got the two holes, and then we've got the tool coming down on the index system from that surface and pocketing it out at two different depths, and then the profile finish pass with the same tool. And once everything looks good, we can close out of the simulation. We can hit post up at the top here, and it will generate the G-code down at the bottom right-hand corner over here, where I can right-click, I can save it, put it onto a flash drive, and send it over to the controller from there with the flash drive. You can see the G-code right here. This is formatted for a Fanuc controller. We've got all of our comments up here at the top with our program number, %sign to start with, and then a whole bunch of comments detailing our machine setup and mill turn job. And then it starts from here with a safety line of code and then tool 1 and facing it from there. So just to recap, we created the 3D model by creating a hex from our shape library, extruding that out 1 inch. We created a circle under Create 2D, going to arc, making the diameter 3 inches here and extruding it out 3 inches in the other direction from our hex. Those automatically merged into one solid. And the reason why is because I used extrude boss. If you wanted to keep solids as separate solids to make an assembly, let's say I wanted to add something here with the square, I could go into extrude curve. Now extrude curve is just like extrude boss, but when I'm creating another solid here, like this one, it creates it separately from my other solids. So a great way to be able to make an assembly. You have your extrude curve function under Create 3D. But anyways, we created the extrude boss of the hex, the extrude boss of the OD, created 2 1/4-inch diameter circles here, and did an extrude cut 1 inch into the OD there, and then created a square on my front UCS and extrude cut that down 1/2 inch from the top of the OD to make my 3D model. Then we get into the CAM side of things. It was under the mill turn job. I created my stock, gave it enough room on the back end to clamp down on, a little bit on the front face to do a facing operation first, and a little bit on the OD to turn down the stock there. Then I created my machine setup. It is with Z-axis going out, X-axis pointed up. Then we did our facing operation, our turning of the OD. Then we get into live tooling with a 2-axis mill feature, and you'll see it's the exact same workflow as if you're doing a milling operation in a milling job. By just selecting the wireframe, selecting the total depth. The only difference really is going to your tool page and mounting a tool onto your station number to be able to set that up on your mill turn machine. And then you've got the same workflow as doing a 2-axis profile in milling, setting up your cutting feed rate, setting up your compensation, if you want to do a side roughing, If you want to do a depth of cut, leave a side allowance for the finish pass, lead in, lead out, corner types, machine sequence, advanced feed rates, and MDI, just like the same workflow as doing a milling job. Then our profile finish pass for the hex. Then we've got our drilling of the 2 holes here. And then again, we set up an index. That's set up under our machine setup. So I right-click on, there we go. So I right-click on machine setup 1. I go to additional functions and I go to add index. This is the same as a milling job. If you've got a rotary table, you can create an index right here under a milling job and select a surface as your index as well. So you hit add index, select a surface, make sure the arrow's pointed outside of the surface rather than inside of the surface. You can hit reverse and click OK. And one other thing that I make a point of usually is when we're programming for an index like this, we want to make sure we're programming on the index by right-clicking and doing the milling operation from that index system. You want to make sure you're not, I'm part of tech support and I've had customers call in before where they say, well, it's milling, but it's still milling on my machine setup. You want to make sure that you're explicitly programming it from the index system. Some customers I've run into, they make an index, but they still program from the machine setup. You can see the feature 2 axis that I just created down at the bottom of the mill turn job. And it's really hard to see, but if you see the arrows next to the features, you can see it being linked to the machine setup. You can see the feature that I created before this one, feature 2 axis, the arrow is under the index system. So that's a good way to make sure that everything is programmed correctly. You've got your milling features programmed under your index with the arrow right below it. This feature that I did is programmed and coincides with the arrows next to the index, next to all the other features under the machine setup. So that's a great way to make sure you've got it programmed correctly. All right, cool. So I think that's about it for our webinar today. Please let me know if you guys have any questions in the comment section. But yeah, that's all I really did today was create the 3D model here, create the facing turning of the OD, milling of the hex, drilling of the holes next to the hex, and then indexing to do the pocket on the side of the part file here. Then I went into start simulation, simulated, and then posted the G-code. Again, if everything looks good in simulation, we go to post, generate the G-code, right-click, save, and put it onto a flash drive to send it to the controller from there. One other thing that I make a note of is with your simulation. You can see when I start simulation, it opens up in a separate window from the BobCAD software program. If you haven't already done this in our newer versions, can be really useful if I want to move it over to a different monitor. That's in our settings. It's a newer option now. If I go to File and then go to Settings, then we've got our CAM page right here to select our simulation as a separate window now. Hit Apply and OK. Can be really useful for mill turn especially. We've got our machine that we can see now and a whole lot of other settings to be able to see full screen here. But yeah, all I do is simulate. Everything looks good. We post and save it, put it onto a flash drive for our machine. So again, this live event is recorded and it will be on our training website, BobCADSupport.com, to be able to review it as many times as you need. So if you had any questions or problems with making the CAD file or making the toolpath, everything's going to be recorded for you guys to be able to design this as I did in the live event and be able to program with all the turning operations and then the live tooling operations to profile around the hex, drill the 2 holes here, and pocket on the side of the part as well. So yeah, I'll sit back and see if you guys have any questions for me in the comments section. If you don't have any other questions or comments, this is the end of the live event. So thank you guys for viewing the live event today. And if you have any questions, please let me know in the comments section. And if you have any questions, comments, concerns after the live event today, you can find our tech support contact info at the top here. Our technical support phone number is 727-489-0003, and our email address is support@bobcad.com. So if you have any questions about what we went over today or anything else in the software program, let us know there, and we're more than happy to help. All right. And again, thank you everyone for joining me today with the webinar live today. We have live events every other Wednesday. So today is March 5th for this event, and we will have our next event on March 19th. We don't have a topic yet for that one. We normally send out an email after this event to ask you what you would like to see in our next event, to make sure that these live events are tailored to your specific needs. So please let us know in that email what you'd like to see in the next live event, and we'll be going over it March 19th. All right, again, thank you guys for viewing the event live today, and hope to see you in the next one. All right, see ya.